sine omega t over what? A times 2 I omega. Oh, look at that. You get all sorts of just delightful cancellations. And for harmonic motion with damping, we have, this is damped harmonic motion, we have E, the A, T, sine, omega T over A times omega. Wow. Who would have thought I would have cleaned up that nice? I would. Lots of them. The last one, you already have done the answer. You know the word, or you know the answer. You may not know that you know the answer. So, make some space. Bring this all together. This lowercase a occurs when there's damping in the system, meaning there's shock absorbers. What happens if there's no damping in the system? Yeah, this A becomes 0. I mean, this lowercase a. In other words, the original differential equation we had, A, y double prime, plus B, y prime, plus C, y equals 0. Capital B is 0. There's no damping. And so what we would have is our fourth case. Our fourth case is undamped motion. So number 4 is undamped. And our solutions are S, I'll just put I'll just write S. S is equal to plus or minus I omega. It's really solving the system of A, y double prime plus 0 y prime plus C y equals 0. Do you remember these? I'll let you catch up. Sure.
You said that was for damped harmonic motion.
Yes, that would be the car bumper with that shocks. This, if I just have A y double prime plus C y equals 0, that was where we started this whole journey. And really what this is the A was the mass attached at the end of the string, and C was the stiffness of the string, which we use a proportionality constant of A. It's the same problem. I know our calculus books kind of hint at it. Oftentimes they give you the solution and ask you to study it, but now you know where it comes from.
Okay.
It's always intended. We're studying it, the other way of writing it is lowercase m, lowercase b, lowercase k. All right, let's see. Last solution. Let's wind this up. So that would be g of t is equal to e to the S2, it doesn't really matter. I'll just put in I omega t minus e to the minus I omega t. All of that is over A times S2. S2 we said is I omega minus S1, which is minus I omega. But wait a minute, have we seen this? Yes. It's that. It's all the work that we did over here. you're like, whoa, wait a minute. It's this. E I omega t minus e to the minus I omega t. Notice here the a's cancel and we're left with I omega minus I omega. In other words, we're just looking at, we're back to this. So in other words, the e to the at is just 0, e to the a is just 0, e to the a is just 0, and the answer is sine omega t a omega. Let's write that. What was that? Okay, so we had, what did I just say? Sine omega t over a. We'll stop there. I don't have all the homework picked out yet for section 2.3. Yeah, for 2.3, so I will be posting that in the next day or two. All right. So for those of you that want, we'll head over to the math lab if you have questions or want to practice work on some homework. Otherwise,